Now, we will perform the Dopcon test, and which we call the penetration resistance of the geosynthetic material as per specification ISO 134333. So, what is that introduction? That this test method can simulate the stress in the geosynthetic material when a rock fall on it. You know that many of the area where there is a landslide, even in Bombay Pune road or many hillside area, there is a landslide, there is a rock fall. So, you should know that what will be the energy and developed, and what kind of the geosynthetic material is required to place and to protect the rock. So, when a rock fall freely on the geosynthetic material from a height, geosynthetics resist the impact and or damage, and consequently gravitational energy developed. So, this gravitational energy, if is can be designated as a E. So, E will be equal to mg into z. So, this energy E will be equal to m into g into z. So, you know that what is E? Is the energy, and that unit is joules, and m is the mass of rock, So, which may be unit is equal to kg, and z is the height of fall. So, z is equal to height of fall. So, this height of fall is designated as m, that is meter. Any height it can fall, it may be 100 meter, 200 meter, 300 meter, 50 meter, and g is the acceleration due to gravity, and that is in meter per second square, and that is equal to 9.81 meter per second square. And this equation mgz also we can write as V, that is volume of the rock, into rho r into G into Z. Or again this you can write, that is rho r, which is the density of the rock, and V is the volume of rock. So, this mass is equal to volume into density. This is volume of the rock, density of the rock, and this is G and this is Z. Again, this also we can write pi into d to the power q divided by 6 into rho w into g of s, this into g into z. So, I am explaining that what is that V. Okay. So, V is equal to volume of rock. You can write that volume of a rock. So, this volume of the rock can be expressed as meter cube. So, this is the V, volume of the rock, and this is the rho r, density of the rock. So, you can write rho r is density of rock. So, density of the rock is kg per meter cube. That means, this will be equal to rho of W into G of S. This density of the rock, rho W into Gs. Now, what is rho of W? Rho W is the unit weight of water. Unit weight of water, and that is designated at kg per meter cube is equal to 1000 kg per meter cube, and this is Gs. Gs is equal to specific gravity. Specific gravity of rock, which is dimensionless. That is equal to 2.7. And you know that r, small r, is radius of the rock, which is meter, is equal to d by 2, where d is equal to diameter of rock. Diameter of rock, this is millimeter. So, that is why this equation has dq by 6. This is the rho r is rho w into g of s. You know what will be the specific gravity of the rock, which is 2.7. You know radius of the rock, that is d by 2. So, you can next this pi into rho r will be equal to d to the power q by 6 into rho w into gs into g into z. So, you know that what will be the diameter of the rock and what should be the radius. So, ultimately you can determine that what will be the diameter of the rock d in millimeter. So, energy E you can write from the equation that pi into d by 1000 whole to the power q, this divided by 6 into rho of w into g of s into g into z. So, this is ultimately you will get the equation for energy. And knowing this value of the g value is known to you, that is here it is given 9.81. Then rho w value is known to you, that is given 1000 kg per meter cube, and gs also given, that is specific gravity of the rock is 2.7. So, knowing this value, you can write this equation, energy will be equal to 13.87 into 10 to the power minus 6 into d to the power q into z. Z you know height of the fall of this material. So, when the rock fall on the geotextile material laid on soft subgrade soil, then the geotextile will deform and also resist the high amount of impact energy. Because it is deformed, it also resists higher amount of the impact energy. Therefore, it is necessary to determine some modification factor. So, this modification factor is given by the Koehner in 2005, and that modification factor you have to take into account for the design. You can draw a correlation between the Andine shear strength and that is in kilopascal. This may be 0, it may be 5, 10, 15, 20, etc. And this is the modification factor. Modification factor. So, it may be the 10, 20, 30 like that. So, you can have a curve is like this. So, from this modification factor, you have to determine what will be the E required. So, you know what is E. So we can write that E required is equal to E divided by modification factor. Modification factor that is designated by M of F. So, E is maximum energy developed if the geotextile is on a hard surface. Then E required is required impact energy of geotextile. So, factor of safety will be equal to E of allowable, this divided by E required. So, you can determine what will be the factor of safety from this test. So, what will be the type of that equipment you require to determine the puncture resistance of the geotextile material. So, you require the clamping system and the frame to support the clamped specimen, and this is the cone with 45° tip angle and measuring cone. So, here you can see that measuring cone, and here you can see that here it is given that in dimension. So, when this geotextile material penetrated and then there is a hole in the geosynthesis material, you can insert this measuring cone onto that hole and you can determine that what should be the diameter of the geotextile material damage. So, this is the diameter in millimeter is given. So, this is the marking in which you will be knowing that what should be the damage of the geosynthetic material. Now, this is the type of the equipment in which we perform this test, and this is the this is the container, this is the container, this is a severe mold, and this white color is the geotextile material then this is clamping arrangement here, and this is the cone which is to be dropped at a particular height. Because there is no soil inside this container, so therefore, the container is to be filled with the water to simulate the very soft soil, and it ensure more practical result. You can see this is geotextile material is clamping here, and this is the pointed cone. Okay. Now, procedure is that secure the specimen between the clamping rings free of slack and place the specimen in the testing machine, release the cone so that it fall at the center of the specimen, and remove the cone and measure the diameter of the hole using the measuring cone which I showed you. Then you calculate what should be the mean hole diameter and you express in terms of the millimeter. So, from this experiment you can penetration resistant, and here in this curve it is given the relationship between the relationship is given between the height of the fall and energy mobilized in joule. So, for the different diameter of the stone, it may be 50 millimeter diameter, 60 millimeter, 90 millimeter, 150 millimeter, 300 millimeter, 450 millimeter, 600 millimeter or 900 millimeter. So, this is the design chart for energy mobilization due to the free fall of a rock of a geotextile material. So, this design chart is only applicable only the geotextile is placed on the firm subgrade soil. So, we know that what would be the diameter of the stone is falling onto the ground for a particular height, and then what is the energy developed. So, this chart will be useful for the design of the rockfall system. I can give the example of the rockfall. For example, that when the energy is mobilized from a free fall height of the rock, and the height of the rock is size of the rock is about 300 millimeter, and it fall from a height of 1.5 meter. So, what will be the energy mobilized by the free fall of a rock with size is 300 millimeter and falling on a 1.5 meter on a geotextile, and geotextile is supported by poor subbase soil and having the unsoaked severe strength is about 4. If the geotextile has allowed the impact strength of, let us say, 36 Z. So, you have to determine what will be the factor of the safety. So, this you have to determine. So, you know that energy equation, from the energy equation you can calculate that E is equal to, let us say, it is in the terms of the dAq and the Z value. So, you can have, let us say, 13.35 into 10 to the power minus 6 into, you know what is the d of q and what will be the height h. So, from this equation you can determine the what should be the energy, that is energy, this is E of maximum energy you can develop. So, this is 13.35 into 10 to the power minus 6 into diameter of the stone, let us say 300 millimeter. So, 300 to the power q and height of fall is 1.5. So, this is 1.5. So, E maximum you can determine 540 joule. So, as the value is substantial by the design, because this rock will fall onto the very soft soil. So, you require what should be the factor of safety, and you have to use that modification chart to determine the factor of safety. So, this is the E maximum which you have determined 450 of joule. So, from the modification chart yes. Let us say this is the modification chart. This is unlaid shear strength by the unlaid shear strength means that is the what is severe value. Okay. So, from this chart and considering the unlaid shear strength of the soil, and then you can determine that what should be the modification factor. So, this modification factor for a particular the unlaid shear strength of the soil, let us say that 13 is the modification factor for a particular unlaid shear strength value. Okay. So, 13. So, what will be the E required? So, E required will be is equal to 540 this divided by 13. So, this will give is about 41.5 joule. So, result of the factor of safety, you can calculate that factor of safety will be equal to E of allowable divided by E of required. So, this will give you 30 of 6 divided by 41.5, because earlier you calculated that this value, that what is given, the 36J, and then you have achieved this E required is this 41.5. So, this will give you that factor of safety 0.87. So, which is not acceptable. So, geotextile material may be damaged. So, you require for some alternative geosynthetic material to protect the rock. Thank you.